Hello and welcome to the course Design Borefields with Confidence. This is the 6th part of the course and congratulations, you're halfway through. But before we jump into what we'll be covering in this part, let us revisit what we talked about last time. Because part 5 was all about sensitivities in borefield design. And we started off with a seemingly simple question, namely, which one is better, a single versus a double U-tube? And in the first chapter, we looked at this question from a thermal perspective, talking about the effective borehole thermal resistance, namely how good can our borehole exchange heat with the ground. And we figured out that there is no definitive answer to this question. It really depends on which flow rate you have, at which temperatures you're looking at. Are you looking at the cooling temperatures or the heating temperatures, for example, which borehole radius you have, which grout conductivity you have. So it really depends on your specific situation when a single versus a double U-tube is better. In the second chapter, we revisited that question, but now looking at it from a hydraulics perspective, talking about the pressure drop. And here, although there is also no definitive answer, we learned that having a single U-tube with the same diameter as the double one always increases the pressure drop. But when different diameters are combined, for example, a single DM40 versus a double DM32, sometimes the single probe has a lower pressure drop versus the double one. So also here it depends quite a lot on your specific project and also the pressure head of your pump to see which solution is the best for your project. In the third chapter, we went away from talking about the borehole internals to looking at irregular configurations, because typically borefields are designed, especially in feasibility studies, in rectangular or regular grids, but in practice it's often irregular. Boreholes are sometimes scattered around the building, and what we figured out is that this has a very significant impact on the temperature profile. So we discussed on how you can work with irregular borefield configurations in GHE tool, how you can import your coordinates from AutoCAD, how you can draw them on a map, and so forth. And lastly, we talked about imbalance. Now, when you're designing a borefield and you have your building load, imbalance basically is a fact of life. Right? It's determined by your building heating and cooling demand, domestic hot water, and so forth. And you have to cope with it when you're designing your system. And we talked about different ways on how we can do that, both minimizing the effective borehole thermal resistance, which we discussed in the first chapter of last part, as well as changing your configuration, and by that changing the long-term effect of your geothermal system. We also learned in this last part that adding other boreholes or adding extra boreholes to cope with the imbalance sometimes has a negative effect, since it can be that your borehole resistance becomes significantly worse if you transition from a turbulent to a laminar flow regime when you're adding another borehole. So that was all we talked about last time, all about sensitivities in design. Now in the 6th part we will revisit the first 2 chapters of the last part, but now with innovative solutions. Up until now, this course has been all about regular probes, smooth pipes, and especially single and double U-tubes in the last part. But of course there are also solutions from the industry, and some companies have developed new type of heat exchangers that have benefits in one domain or the other. And we will start off this chapter when talking about the turbo collector, which is a product from Movitech. It's a regular, smooth, circular probe, but now with internal fins that enhance the turbulence at lower flow rates. And we will discuss how this impacts the thermal and hydraulic behavior of your geothermal systems. In the second chapter, we will be looking at the Movi Ellipse, which is, let's say, the younger cousin of the turbo collector, which is now an elliptical probe, again with this internal fins to enhance the turbulence. We will also discuss the effects on both the thermal and hydraulic design of your geothermal system. And lastly, we will be talking about the Gerotherm, Vario and Flux probes from the Swiss company HK Gerodur, which are again round pipes, but now with a varying wall thickness in order to minimize the pressure drop. Now these are, as we are creating this course, the 3 probes we will be discussing But over the next months, we will be adding more and more chapters to this course when we are also adding other probes into GHE2. So chances are that when you're looking at this video, there are already other solutions implemented. So for now, let us start with talking about the turbo collector in the first chapter.